Okay, class, today we're going to be doing log properties, so make sure you have that sheet in front of you. So for this activity, it's going to have us change our mode key on our calculator, and we've talked about how to do that before. So I'm going to go to my calculator, and I'm going to go to second mode. So I'm going to go in to change my mode key. So it's telling you specifically to make sure that number 1 is highlighted in the floating row. So I'm going to go down to float, and I'm going to hit enter so that 1 is highlighted. And then I'm going to get out of there. Second mode is to quit. So now this is going to round our answers to the first decimal place or the nearest tenth. So now I want to evaluate these logs using my calculator. So when I go to my calculator and I plug in log of 5, it returns a value of what? 0.7. So now I'm going to do the same thing for 50 and 100. So when I do log of 50, and as a general practice, just make sure you close your parentheses. And then I do log of 100. I get 1.7 and 2. So now, based on these answers, I want to see if I can determine the logarithms of other numbers. So because I know that 50 times 100 is 5,000, so if I look at 50 and I look at 100, I'm wondering if there's some correlation to what there will be. So let's go to our calculator and plug that in. So if I plug in log of 5,000, what do I get? 3.7. Now, don't I notice that 3.7 is what these two numbers would have been together? So what I found out, if I rewrite these in terms of 0.7, 1.7, and 2, is 1.7 plus 2, or log 50 plus 100. So now I'm going to do the same thing for the next one. So now I want to know what log of 5 times 100 is. So 5 times 100 is 500. So if I look at log of 5 and log of 100, I get 2.7, which is the same as saying 0.7 plus 2, or log of 5 plus log 100. So now go ahead and write these down, and we're going to talk about why these rules are what they are and how they come to develop what our properties are. Now notice when we're dividing, what do we end up doing? When I ended up dividing 100 by 5 to get 20, what did I end up doing to my numbers? I ended up subtracting. So that sounds like my exponential rule. So remember, when I multiplied, I added, but again, when I divided, I subtracted. So that shouldn't be a hard rule to remember. So what pattern occurs and what rules can you develop? The logarithm of a product is the same as the sum of the individual logarithms, and the logarithm of the quotient is the same as the difference of the individual logarithms. Okay, now let's focus on the bottom part of the paper. So now I'm going to look for patterns in the table below. I know that 5 squared is 25. So if I were to plug in the log of 25 on my calculator, I get 1.4. So I noticed that 1.4 is twice as big as the 0.7 that I had above, correct? So I can deduct that 2 times 0.07 will give me 14. So it's twice as big as my log 5. So what happens when I try to do log of 125? What do I find? I get a 2.1, which would be, that's correct, 3 times as big. So what do you propose we would get if I did 625 and I got 2.8? That's correct. It would be 4 times as big, then it would be 5 times as big, and then it would be 6 times as big. So what patterns are described here? When the exponents inside the log increase by 1, the answer increases by 0.7. Or exponents inside the log can become factors, something you multiply it by outside the log. That's an important rule as well. Now remember, pause your video here if you need to write all this down. Okay, let's go to the next page so we can come up with some of the rules. So if I have log base b of x times y, what did we deduct on the front, on the first sheet that we were going to do? We were going to add logs as long as they're in the same base. So the log of a product is the same as the sum of the logs of the numbers. So multiplication inside a log changes to addition outside of the log. And so division inside the log, turns into subtraction outside a log. Now, what do you notice about the p? Where does that p value go? The p value goes in front of the log. So you're gonna know that it's the same as a power times a log. So what the function we're going to use here is multiplication. That will become your a. Okay, make sure you make note of the special cases at the bottom. When I have log base b of b to p powers equals p, look at this equation over here. So you notice that I'm going to end up with 2 to the x power equals 2 to the 6th power, so x is going to equal 6. So if the log base and the argument are the same, it is always equal to the power. If the b's are the same here, and the p's are the same here, then my answer is going to always be what my p is. So on the bottom example, it's showing log of b base b equals 1. If the log base and the argument are the same, it is always equal or understood to be the power of 1. So make sure you understand that rule as well. We're going over that more tomorrow. Okay, now let's go to the third page. So now they want you to try these out with the calculator. So I'm going to go ahead and plug them into the calculator and tell you what the value is. And then we're going to look at the bottom to see how we need to rewrite these. So if I have log of 2 equals 0.30 and log of 450 equals 2.65, what do I know about those two numbers? What do I need to do to these two numbers? I add them because my logs are the same, so I can add them together. So what do you think I'm going to do to the next two? The base are the same. They're both in the common base 10, so I'm going to add those as well. Now, if I want to know what log of 12 is, how would 36 and 3 give me 12? I would have to divide, right? So what am I going to do to my arguments? I'm going to subtract. But if I want to turn log of 11 into log of 121, I'm going to have to multiply 11 times 11, right? So then I'm going to have to take the 1.04 and multiply it times 2. Now I want you to rewrite the logarithm as a single expression. If I have log of 2 plus log of 5 and they are the same base, what would the 2 and the 5 become? That's correct, log of 10. So if I have log of 500 and log of 5 and I'm subtracting, then what would they become? I would divide and I would get 10. So looking at example G, if I have log base 5 of x minus log base 5 of 10, what can I do to combine those? Take a moment and really think about this one. I'm going to end up, because I'm subtracting, I'm dividing. So it's really x divided by 10. Now what's going to happen with h? Where is the 2 going to go? I'm going to write this one out because I want you to see it a little bit clearer. Where do we know that the p ends up going? it becomes my power. So I'm going to end up having, let me make that a little smaller. I'm going to end up having this to the second power. And remember that it's really giving me x plus 1 times x plus 1, correct? So this is why I end up with this. X squared plus 2x plus 1. So I'm going to have to take my 3 on the next one and raise that to the power. And 2 to the third power is 8. And m4 to the third power would be 12. Okay, now let's look at the bottom page. Okay, so now let's look at the bottom of the paper. So when I look at simplifying each expression, if I want to simplify log base 5 of 5 to the 7th power, what am I going to do? What do you notice here? That's correct. My base is the same as my argument, right? So based on the rule on the other sheet of paper, what do I know my answer is going to be? That's correct. It's going to be the power of 7. What about the next one? Even though it doesn't say to the 1 power, because my basis is the same as my argument, I know it's going to be to the 1 power. What about L? What base is that when it's not mentioned? That's correct. It's the common base of 10. So they match up, so my answer is going to be -4. And then on M, my bases are the same, and I have a 3 and a 1. So what am I going to end up with? I mean, a 3 and a 4, so I'm going to end up with the 1. Now, I want you to go ahead and take a look at the last page. Guys, there's only 7 problems there, and I'm confident that you can work those problems on your own. So try to go ahead and work these, and I'll see you in class tomorrow. Have a good night.